We are not ready for what's coming. And we need to think about our next steps very carefully, lest we all get lost in the darkness.
We're going up!
Get me into space.
Hey, good to see you. And just wait. I know how it looks.
Anything.
Yeah.
A kilometer underground. Anything is going to be harmless there.
Yeah.
You work for an AI, and then an AI wire transferred you funds into your account, and then you have a machine daddy.
Oh, yeah, your download speed is fast today.
Kyle Hill, everybody! He's the next generation of science communicator.
We are here on set to find the next generation of people to do just that. This is a nuclear reactor, and it's made out of glass. Thank you all for having me. If you told me that the Thor that you bought off Temu would be here at the IAEA, I wouldn't have believed you.
Great science and cutting-edge science creates amazing art and science fiction and ways to push our thinking in society further.
This radioactive piece of Trinita, a tangible timestamp of the millisecond that we entered the nuclear age.
Are you the monarch? Because I'm crowning.
You can't irradiate the radiation.
I can tell you a nice joke. A robot walks into a bar.
Don't get on the... No!
How do you look more CP than me, though?
What's the utility? Why is this fun? Look at all that crap on the screen. Sick. Oh, I can't believe I pre-ordered the premium edition. Oh.
I'm a little afraid it's too matchy-matchy, but Chad, I do like it.
Get in, get nerdy, get with your boy here.
Learn, play, and win the science victory.
Kyle Hill in the chat. Oh my God, that guy's hot. It's like Legolas from Lord of the Rings.
2 chicken tendies. No. Hold the chicken.
Chat, welcome. Chat, welcome. Happy to be back. I'm just checking that I wasn't muted. I was muted for like 3 minutes on the gaming stream yesterday. Chat. Or 2 days ago. Chat, welcome. It has been too long, my friends. It has been too long. Happy to have everybody here, of course. I think the last live stream we did on this Chan, the Science Man, was 6 months ago. So happy to have everybody here. Happy to see all my newbies and my oldbies. Of course, today I'm trying, like any good scientist would, I'm going to try something a little new. And you all will be my guinea pig audience for such experiment. We're going to go through the science of the new Fallout season, episode by episode. This is something that I... Turn it down, Kevin! And keep the door open. I don't trust her. You can only wear a kigurumi for so many days in a row before it gets suspicious. All of you over on patreon.com/Kyle Hill said you may have wanted to have a little watch party recap science of each episode here with Yo Hombre here. And that's what we're going to do today. We'll spend a little time, maybe 1 to 2 hours or so, going through everything I wrote down in my uranium-laden notebook. Custom. And first on the docket today is Cryonics, because it is a big part of the Fallout series, and it was a big part of the episode 1. All this is to say that we are going through each episode of the new Fallout show. If you haven't seen it, that's fine. I still hope to teach you something interesting. If you want to see it, we will be spoilering season to episode 1 in the chat. I will probably say something at some point. So you can come back to this live stream after it is live. That's the benefit of technology. Happy to have everybody here, of course. Of course. Of course. Is it uranium 235 or 238? So, science time. When you have a depiction of an atom like this, it is not showing the number of neutrons. This is the number of electrons and their in their orbitals. Okay, so even though this is not an accurate picture of an electron, electrons are probability-based. They're not in any one place at any one time until you try to find what place and time they're at. But so this is just a depiction of the electrons around the atom with 92 protons, 92 electrons in their different orbitals around the uranium. Boom! Bam! Boom! Starting out strong. Get well soon, Liz. Oh, also, this episode is dedicated to Zoe, my YouTube crush Zyla Fox Lynn's shop assistant. She said she wanted something like this, and here you go. Clip it! Send it to her, Zyla. What's the best way to freeze my head later for revival? We'll get into it. First, join me in the laboratory. I've had a lot of caffeine. Welcome. Welcome as usual. Kevin, turn down the music. Does she only have black corsets? Jeez. Kevin's got a new girlfriend. I don't trust her. The heels on her boots are too high. Like, there's a proportionality thing that's throwing me off there. So, yes, chat, we're going to be going through the first episode of Fallout. Season 2, if you want to talk about it, if you have any questions about Fallout in general, this is going to be kind of just a going through. I wrote down in cryogenical... I pressed the wrong button with my notebook. We'll be going in cryogenical, I mean chronological order. Some stuff I wrote down. We can start with the cryopods in Fallout, and we'll do that in just a little bit. Welcome, Dupalis, Zombie Cubed. We're also streaming on Twitch if that's your preferred viewing experience. The Dupalis, 1990. We also have Penitent Man, Steve Wuthers, 14-4, Stefano Mevrega, Aaliyah, as usual, My Cat Food, Perito, Peter, 612, thank you for the $5. I appreciate you. Of course, if you really, really, really want me to see something during this discussion, you can always try Super Chat or anything like that. I'll try to get to as many questions and comments as I possibly can. But two things, if you want to interact with the rest of this nerdy audience all day, every day, patreon.com/Kyle Hill. And I will show that later because that's not showing up well on camera. D-Child with the 5. Hey, Kyle. Hey, Kyle, I sent money to a guy on the internet who said he would process my application to be a Kevin, but I haven't heard back. Well, a Kevin isn't something you become. It's something that is grown by me from that. See that? That's like, you have to... I control the genetic makeup, especially the epigenetic makeup. I love flipping those switches. Welcome. You ever freeze your head wrong? Now that will ruin your morning, for sure. Let's say that adaptive radiation can be sped up after a nuclear war. That's a fun way to spell that word incorrectly. How fast could that kind of evolution actually take place? You know what? I think it's time to get into the Fallout science, huh, Chad? Let's do it. Join me in the chat room. Beep. Boop. Join me in the chat room. Chat, welcome. So, let's start off from the very beginning. At the beginning, oh, by the way, the first episode of Fallout 1 Season 2 is very good. I liked it quite a bit. I thought the acting was very good. The set pieces, especially in the beginning, in Nipton or Novak, was very fun and very good. The music selection was fantastic. The actor who's playing Mr. House, I think, is really good. And what we started out with at the end of that little fight in Novak was Fusion Core healing the ghoul. Yeah, Walton Goggins is incredible. I agree. Yes, human gazpacho. So, ghouls in the Fallout universe have the interesting property that they are healed by radiation. Now, I don't know of any process like, so he gets his neck all cut up by some wire and rope, and then he holds Kyle Hill's nuclear fallout honey next to his, or a fusion core, next to his neck, and you can see the green radiation, not a thing, coming out and healing his wounds. And that is a canonical ability that ghouls have. Now, the good, as I like to say, the good thing about radiation is that, well, the bad thing about radiation is that it can kill living cells. The good thing about radiation is that it can kill living cells. So going all the way back to Marie Curie, back in 1896, and then going all the way back to, no, wait. That was Henri Becquerel, who discovered natural radioactivity from uranium salts back in 1896. A couple years after that, I think 1898 or so, Marie and her husband, the Curies, discovered that when working with radiation tended to kill fast-growing and or diseased cells more quickly and more readily than healthy ones. And so they immediately recognized the application of such radiation in the treatment of tumors and for medical diagnostics. And Marie herself was a big proponent of using radiation for medical treatment, using radium, polonium to treat cancers, taking X-ray machines onto the battlefield to rapidly image soldiers' wounds during World War I. And they drove around in little trucks called Petite Curies. I'm not even joking. I'm not even joking. Chad, you think I'd be joking, but I'm not. X-ray machine in a car, World War I, after the Curies really they discovered, but they started delving into what radiation could do, and they advocated for its use in the medical context quite heavily. Now, like I said, the good thing is that radiation can kill cells like cancer cells. The bad thing is that it kills living cells. So when you're talking about healing in the context of radiation, first and foremost, you're always talking about cellular damage. Okay? So how would it heal the ghoul? That's, there's some hand waviness there. If I wanted to link this to real world science, like I went to a Fallout event and I tried to get, I was about this far away from Todd Howard, and I'm trying to get to be a science advisor on the show because I'm not sure anyone's doing that. By the way, Todd Howard, about this tall. It just works. Anyway, it just works. Hello, Kyle, one of my favorite bungulators. Good man, good man. Good latty doos, good latty das. Zach, welcome. Hell yeah, hell yeah. So, radiation in the context of healing the ghoul. If I was being a science advisor on some sort of show like this one, I would say it is closest to the idea of radiation hormesis. Now, you may have heard me mention radiation hormesis in my linear no threshold video. Spoiler alert, I staked my reputation on that video on the main channel, and there's some news about that that may or may not happen in the next week or so. Don't tell anybody. But I mentioned that in the context of that video because it seems that the more we discover about low-level ionizing radiation, the more it seems that not only is it not harmful in a linear extrapolation kind of way down from what an atomic bomb would put out, which is to say that any level of radiation isn't. Every level of radiation isn't harmful. There does appear to be some sort of threshold below which it seems harmless to humans. That threshold, if you're interested, being around 100 millisieverts in an acute fashion. So cute. 100 millisieverts is a lot in the context of your everyday life. You're probably not going to encounter that even in a year. I think the average American gets about 6.2 millisieverts per year. So you can get more if you go through a lot of medical treatment, but 100 millisieverts is the threshold. Anyway, in the context of all that, I was talking about radiation hormesis. Now, after decades of study, it appears that not only is there a threshold, low levels of radiation might actually be beneficial to human health. Now, I didn't go that far in my video because it's even more controversial than linear no threshold or LNT. But there are what was the figure? I think like 30 to 40% of low-level radiation studies show some level of hormesis. Now, when I say beneficial to human health, what do I mean? I mean that there is some adaptive response to a above background low level radiation field. Your body, when hit with this low amount of radiation, immediately deploys cellular repair mechanisms and other mechanisms within the body that actually have a proactive beneficial effect. We can get even crazier with this. And again, I say this in the video. The survivors of Hiroshima, who were nuked on August 6th, 1945, those that received below the threshold dose of radiation actually got less cancers than people who were exposed to no radiation. Now, let me repeat that. Yes, high levels of radiation at ground zero, harmful. Below a threshold, though, the people who got that radiation dose below a threshold developed less cancers over time than people that weren't exposed to that radiation. Think about that. I could go even further. If you look at young Russian men during the period of 1986 to the mid-90s, the young Russian men who worked as liquidators at Chernobyl, who received a below threshold dose, actually experienced less mortality overall than young men that did not work at Chernobyl. So, it seems that there can be, or at least the data is hinting that, there might be some beneficial effect of low-level ionizing radiation because it stimulates the body's natural cellular repair mechanisms that evolved, just like with all life on Earth, to resist ultraviolet radiation from the sun, uranium in the ground, uranium and thorium daughters, radium, radon, that sort of thing. So, if I was talking about the ghoul healing itself with radiation, I would link it to some sort of hormetic effect like that. And of course, if you doubt anything that I'm saying about the A-bomb survivors or the Chernobyl liquidators, I have all of that information in my linear no threshold video on this channel, with all of the links to the studies and all of that stuff. That video was also independently fact-checked by experts from the American Nuclear Society, if you want to check that out. So you're hitting up tanning beds now? So what is interesting, Snappy, ultraviolet radiation, the kind of ultraviolet radiation that we are exposed to here on the surface of Earth, is not ionizing radiation. UVA and UVB is not ionizing. It does not have enough energy. The photons do not have enough energy to rip electrons from atoms and therefore change how they work inside the body. However, UVA and UVB does mimic the damage you can get from a radiation burn. It mimics it. It's not the exact same mechanism. Okay. I will also point out that that radiation does not get past the skin. Okay. That's why we should buy your nuclear honey. Hey, if you want to microdose some... How much did I calculate this as? 0.12 nanocuries of cesium-137. If you want to start... I do. Look, I've already chugged a little bit of that. Now, on to the main event, I guess, for today. The next thing that happens in Fallout Season 2, Episode 1 is we see Norm still stuck in Vault 31 with a bunch of cryopods filled with Vault Tech executives. Of course, cryopods, hibernation, all of that sort of thing all that sort of stuff is a mainstay of science fiction, right? Cryopods are everywhere in science fiction. It's how sci-fi authors get around the space travel time problem. It's how Fallout gets around staying frozen for 200 years problem. All of that. All that. So what is cryonics? Cryogenics is the study of stuff that I think is below... It's not a hard and fast line. It's like negative 185 degrees C, I think, is when we define something as cryogenic. Cryonics is the application of cryogenics to humans as some sort of life extension technology. Now,
but Kyle, how can you say that it's a scam?
I will enlighten you. Or I will try to. Why cryonics is appealing in theory is that when you freeze something really, really fast through the application of, say, cryogenic liquid, you reduce the cellular damage to that thing. Okay? So why do we flash freeze foods with cryogenic liquid and gas? Liquid. Why do we store samples of tissue and DNA and other things like that in these incredibly cold environments? It is because the freezing process happens so quickly. Okay? So when you freeze things slowly, ice crystals from the water that is in every tissue, the ice crystals have a long time to grow and form. And I don't know if you've seen ice crystals, but they are not round. They are spiky. And when you give those ice crystals time to form, it literally ruptures the cell walls of tissue and destroys that tissue. This is what freezer burn is. Freezer burn is the degradation of tissue from the growing of these ice crystals. So you can imagine that if you wanted to freeze yourself into the future and beyond, you wouldn't want to freeze a human body slowly. And human bodies are a lot of water. Human bodies are a lot of water, and water can hold a tremendous amount of heat energy because its heat capacity, 4.184 kilojoules per kilogram? Heat capacity of water. I'm the smartest man in the world. 4.184 kilojoules per kilogram. So water can hold a lot of heat energy. Okay. So if you want to cryogenically freeze someone, you want to freeze them fast. That's why I use cryonics. Okay. Now, at some point, some rich people globbed on, literally globbed in these cases, some rich people globbed on to the idea that, well, what if you could freeze me? Could you unthaw me at a later time? Now, this is where the scamminess starts to creep in. The ice crystals of scamminess start to grow. I don't know who gave popular culture this idea, but if your metabolism stops, you are dead. Once your metabolism, which is all the chemical reactions put together in your body, once that stops, you are dead. I don't know who gave these futurists, like the Kaku. I'm not high on the Kaku right now. I'm not too big on the Kaku. I don't know who gave these futurists this idea that if you stop the metabolism of a living thing, if you unthaw it, the metabolism will restart. Who said that? Who told Michio Kaku that? Which one of you was it? Which one of you singularity weirdos was it? Why would that occur? Yes, Elijah over on Twitch, I'm about to mention that. Why would that occur? How would that occur? Why are we just assuming that would occur? Now, there are cool examples in nature of basically cryonics happening. And here is a picture of just that happening. This is the wood frog. The wood frog has a chemical, well, has stuff in its blood, let's just say that. I wasn't saying, to be clear, I wasn't saying Michio Kaku specifically thinks cryonics is a good idea. I'm just saying he's the most well-known, popular futurist guy. And he needs new talking points. We get it, quantum. This frog has, I think, a chemical compound with urea, like in your pee, circulating in its blood, such that it makes its blood has antifreeze in it. This frog does not freeze solid. Its metabolism goes down to 1. If its metabolism was 1,000, it goes down to 1. During the wintertime, this frog will basically die. But there's still just a little bit of metabolism going on. Just enough such that when the spring comes, these wood frogs thaw out and that metabolism grows and grows and grows until it's back and doing its hippity hoppy, don't stop the rocky bam bam boogie, say up jump the boogie again. Okay. So this frog has adapted to bring its metabolism basically down to 0. What is that called? It's called, I think it's called cryptocurrency. No. Cryptobiosis, I think. Right. Cryptobiosis, going into a state like tardigrades do, where they dehydrate themselves and they go into a state of basically zero metabolism, but they do not stop. Okay. Cryptobiosis, not meiosis. Let's just double check here for our own. Let's do a sanity check here. I've already given. Leave me alone. Search for the word metabolism. Yes. Okay. So, example: the tardigrade. This is what I'm talking about. I'm saying that the animals that can endure this cryopod-like state, their metabolism goes to basically... What did I just click on? Their metabolism goes to basically nothing, but not zero. They are evolved to do this. What happens when you are not evolved to do this? Don't give to Wikipedia CEO makes like $500,000 a year. So... Should the most useful repository of knowledge in human history not pay people? I'd pay him more than that to keep Wikipedia around. Anyway, what happens when you try to apply the same idea and process to a human? You have this. This is the story I keep... Yeah, no, that's what I'm saying. I'd give them your... Yeah, I would too. I keep coming back to this story when we talk about cryonics. I mentioned this story. It's very well written. It's on bigthink.com. It's called Cryonics Horror Stories. The gruesome fates of futurists hoping for mortality. So when the rubber meets the road in cryonics from a biological standpoint, you take a dead human and you put it in a cryogenic environment for years, and even though it's in a cryogenic environment, that tissue will start to degrade. Now, what I also point out about... See? We get it. It's quantum. Jeez. What I also point out about cryonics, why I say it's a scam, and this is a very Fallout-y, dark humor kind of thing, a practical kind of thing. Even if cryonics did work, which it doesn't, the people managing these companies and technologies are still human people. The stories in here are filled, this story is filled with stories of people not paying to keep their loved ones frozen, of companies running out of cryogenic liquid to keep people frozen. Very real human Fallout-y kind of reasons where, like, oh, the CEO got arrested and now there's no more liquid. And they turn into a ghoulish, grotesque mass of flesh. This is exactly what you would expect. What about the vacuum of space? The vacuum of space is even more difficult. Zachap over on Twitch. The vacuum of space is even more difficult because the vacuum of space, why does cryogenic liquid freeze stuff so quickly? Why does liquid nitrogen freeze stuff so quickly? Part of it is because it can touch and convect heat away from a material. 3 kinds of heat transfer. There's conduction, touching. There's convection, a fluid touching and moving away and coming back and touching like your oven does with air. And then radiation. Pew! That's 3 ways that heats transfer. In a pool, you get so cold so quickly because your body, being at 35 degrees Celsius, or thereabouts, your body is in contact with water that is colder than you, that is constantly touching you and circulating away, thus continuously removing heat. And you're also radiating heat away, kind of like a light bulb does, like 100 watts, something like that. Something like that. That's what cryogenic fluid does. 2, convection conduction. In space, much like the spazio behind me, afuera, nothing is touching you and no fluid is convecting around you. So the only way to lose heat in space is through radiation. I have seen estimates that it would take days for a human body to freeze all the way through in space. Days. And that is not flash freezing. Okay? So why I say that cryonics is a scam is much the same reason why people are saying that how AI is being pushed right now is a bubble and or a scam. It is, right in its current iteration, it is a technology that a lot of rich people got really interested in because of what it could possibly do and then threw a bunch of money at it, but the practical reality of doing it didn't like align with how humans work, and now there's a lot of mess. You know what I mean? So, that was our first and second jaunt into the Fallout universe. What else happened in that episode? What would you guys like? There's brain in a vat. There's shooting down nuclear missiles. I'm reading from a notebook. Cold fusion and mind control. Does any of that sound interesting to you? I'm going to take a little sippy sip of my wee-wah. This is just episode 1. Episode 2 isn't out yet. Is the speed of the universe dependent on the speed of light as a standard? Nothing can go faster than the speed of light. I wouldn't say it's a standard. I'd say it's the speed limit. Didn't you cover cold fusion already? I covered it in an entire episode. Viability of explosive rifle rounds. There's explosive and incendiary rounds already. Do you think the constant fuel expenditure from levitating robots would contribute to climate change? Sure, if there was enough of them. But remember, in the future of Fallout, everything is run on fusion, and fusion does not produce nuclear fission and fusion. Neither produce any greenhouse gases. That's why they get a thumbs up. Veritasium had a video talking about something being faster than light. No, you can get things that are quote-unquote faster than light if you bend the definitions a little bit, but nothing with mass can travel faster than the speed of light. Trust me. I know Derek, personally. Do you think atomic grenades will be a thing? No. The reason why atomic grenade science time wouldn't be a thing is because the critical mass that you need, I think even pure uranium-235... Just a second, I'm going to get on a watch list real quick. 1 second. Critical mass, pure U-235. I think it's like 100... Yeah, it's 100 pounds. So, you have a critical mass of uranium-235, which is 100 pounds. Plutonium-239, much smaller critical mass. But the point is that any apparatus that is going to try to make that go prompt critical and explode like an atomic bomb is going to include a lot of other parts to that bomb. That's why Fat Man and Little Boy, uranium and plutonium, respectively. I'm fact-checking myself in real time. If you can't listen to me, who can you listen to, right? I always get those confused, what their fuel sources was. Little Boy was a plug-type explosive weapon, while Fat Man was an implosion-type weapon. But Little Boy was uranium. Fat Man was plutonium. Yes, I think I got that correct. Anyway, science. Anyway, the problem with a grenade is that, by definition, that grenade is going to be throwable, correct? And if you have something that has to be, at minimum, the best it's going to be is just 100 pounds of that material, and then some other stuff. The worst case scenario is going to be much bigger than that, because you have less than critical mass, so you need other stuff around it to make it go critical by imploding it or whatever. So you're going to have a hand grenade that no one could ever throw. Even if you could throw it, even if you were that giant mountain of a man who just literally shattered Jake Paul's jaw, even that guy would not be able to... Joshua Johnson? Anthony Joshua? It's some combination of those three words. Even if you were that ginormous... Oh, God, he's so hot. Even if you were that size of a man, you're not going to be able to throw a grenade outside of its detonation kill radius, and you would just die. You know what I mean? Kyle, can a black hole get black holes inside it? I don't know. Ask Michio Kaku. Do you know how I remember the difference between Little Boy and Fat Man? So, it's very Fallout-y, actually. Little Boy is a gun-type weapon, which means that it has a subcritical chunk of uranium. Yep. Subcritical chunk of uranium, and then another plug of uranium that it fires into that other plug to make it go supercritical like that. And I think of a Little Boy with a BB gun. Beep, 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 beep. The Fat Man, I think of a big... I think of a big guy like that imploding his big belly in an implosion-type weapon with plutonium. 239, which you get naturally out of nuclear reactors, which is why we're so worried about the proliferation of during reprocessing of nuclear. I should get a PhD for how much I have accumulated by proxy. Anyway. Cryonics is not a scam. It relies on future technology like nanites. Totally possible. Now, how would I sound if I was a rich person asking for rich person money and I said, well, the technology doesn't exist yet, but you can give me $30,000 today? Go ahead and press X on that. Anyway, chat. What's Let's talk about something important. In my book. So, it is canon now in the show that why New Vegas or Las Vegas wasn't really destroyed was because Mr. House developed a Iron Dome-like technology that allowed him to shoot down incoming nuclear missiles. Okay? Now, this has very real applications in the real world. Mutually assured destruction, deterrence, proliferation, non-proliferation. A lot of this is hanging on the hopes that no one's going to be silly enough to do it, and then if someone does do it, at least the public thinks, well, at least maybe we can shoot it down. Okay. Now, there's a lot of scary stuff you can read about this, but I want to scare you a little bit because nuclear weapons are absurd and should be banned internationally. We have done so much in the nuclear weapons space in the intervening years since 1945 and 45, we have made nuclear weapons unshoot-downable. Okay, I want to be very clear on this. I think a lot of the public has at least thought at some point, well, you know, maybe we could save ourselves. The current technology that we have is less than a coin toss in its ability to shoot down one nuclear missile. So you have less, depending on where a nuclear missile is fired from somewhere in the world, you are going to have less than an hour, in some cases 6 minutes, less time than we've been talking today, to decide whether or not to retaliate. The time scale of reacting to a nuclear weapon strike is absurd in the first place. No single human on Earth should have to decide whether or not to annihilate 100 million people in 6 minutes or not. Okay. So I think a lot of like I said, the public's idea of relative safety is predicated on the idea that we can shoot these down. Our current systems have been estimated to be about a coin flip. One missile coming in from a rogue nation or Russia or China or something like that. Less than 50% chance that we could fire something, and you'll hear this a lot, it's like shooting a bullet down with a bullet. If we have the proper tracking technology, that we would be able to do this. Less than 50% chance. Now, if that is a less than 50% chance, you don't have to be Mr. House to realize that a 50-50 chance of killing 1 million people in a millisecond isn't something you want to spin the roulette table on. It's completely absurd. It's inhumane. But like I said, nuclear missile technology has come a long way since 1945. Not only are the missiles that are underground manned by a bunch of teenagers, mostly teenagers in the middle of the United States, 50 feet underground, about 1,000 to 1,200 teenagers in the military operating these things and keeping track of them, and I'm not exaggerating. It is roughly 18 to 21-year-olds underground, about 50 or 60 feet in the middle of the United States, manning 10 megaton nuclear warheads. Warheads that could kill 1 to 3 million people faster than you can blink. Okay. Not only do we have this incredible yield increase, now in missile technologies, there are dummy warheads. So there's not just warheads, there are, I don't know the actual number in modern weapon systems, but there are more than one, I mean...
Kyle, why don't you just check?
All right. I am so on a watch list right now. How many dummy warheads in a modern nuclear missile? Don't arrest me. Beep boop. Okay. Now, we talked about having a less than 50% chance with modern systems to shoot down a nuclear missile. Okay. Now, when you do the quick math, all you got to do is take 50% and multiply it by 50% for every single dummy warhead, in addition to warhead, which could be dozens. And that will be your chance of not getting nuked at all. So let's just say, I don't know, let's say one nuclear missile is coming your way and it's pointed at New York City, or I'm clicking on the wrong thing, or let's say it's pointed at your hometown, okay? And it has a dozen dummy warheads in it. Has a dozen dummy warheads, one warhead large enough to obliterate everyone you've ever met. This is the percentage chance that you could shoot it down. Again, you don't have to be Mr. House to see that. That's not a ring-a-ding-ding good chance there, huh? While politicians right now are talking about Iron Dome, Golden Dome kind of technologies, that build-out is going to take a long time. We have to constantly maintain and refurbish weapon systems. We have to produce new weapons in the state that we are in. And even modern weapon technologies right now are going to annihilate that build-out for the foreseeable amount of time. Okay? So all this is to say that in an all-out nuclear war, the real chance that Robert House doesn't get obliterated in a single city in Vegas is very small. Now, the conceit here is that, he's a genius billionaire. He's actually a genius, not like some people, who's just a glorified shit poster. He's actually a genius, and he develops a private weapon system that can actually do that. Okay. It's not the craziest thing I've ever heard, but I just want to highlight some of this for you, because the current state of affairs that we are in regards to nuclear annihilation is completely untenable and absolutely terrifying. And it should terrify you. How we doing, chat? Are you enjoying this? So this is an experiment, right? To talk through some of the major topics in each episode. Would you want to come back and do this each week with me? We absolutely can. I'll do it maybe each Saturday or whenever today is. Maybe each Saturday we do it so people have enough time to watch the episode. We can do that. Would you like that? Well, in Fallout, they have lasers that actually work. That's a good point. But the current range of lasers that can shoot stuff down, like we have on naval ships, I don't know if it would be too late, right? Because, a giant megaton-sized nuclear weapon, I'll show you. Now, the kind of range that you need... I'm going to select Los Angeles. I'm in Los Angeles in this map. Now, let's say... Why isn't it showing the drop-down menu? That's weird. I'm gonna Minuteman 1 warhead, which we have. And I'm going to show you, I'm going to detonate this thing. Now, you better have a laser weapon that can get outside of the range, can at least shoot something down over a mile away. Because the fireball alone, not the blast wave and thermal effects, which are much bigger, okay, just the fireball is over a mile wide. We miss you. I'm here. 100% here for a weekly follow-up. Okay. By the way, like I was saying, estimate for fatalities from just one bomb. That's where we're at right now. Can we use smaller nukes to shoot down nuclear missiles? That was actually an idea. Using smaller nukes to shoot down incoming Russian bombers that may have nukes themselves. That was this idea. Or rather, if you want to learn all about our idea to do that, that was this video, which you can watch right here. Wish you weren't so dismissive of Cryonics. Not every company promoting it is a scam. Look at Alcor. Although, there are very few people watching the stream, so maybe I won't do it each weekend. Hey, but if you enjoy it, you enjoy it. I enjoy being here with you, of course, as always. The thing about Lutimo, nuking a meteor could be a good idea if it was far enough away and you could hit it. What you don't want to do is you want to alter its trajectory slightly, but you don't want to obliterate it close enough to Earth and then create a billion different smaller asteroids from the explosion and then they all hit Earth. You know what I mean? Kyle, I want you to be harsher on Cryonics. Okay. No pressure or force, so what is affecting it? Thermal jetting? Well, you're a missile or a bomb like that, you're hitting the surface of an asteroid, and and that explosion, like a meteor impact or something, is ejecting material. It hits the object in space, and it ejects material from the crater, and that acts to be the mass release. The reaction mass, like in a rocket that goes out in one direction and pushes the thing in the opposite direction. Yeah, you're right. Everyone is probably traveling right now. And New Year's, I am not traveling. I'm staying at the facility. I'm working on speaking of which, join me in the laboratory. Ablative propulsion. Yeah, that's cool. So we're working on a lot of stuff here at the facility. I hope you're going to join me for all of it, of course. We have some big things coming up. We just did an experiment, again, by turning some Fallout streams into a full Fallout Science video on the main channel, if you want to check that out. We have an esports organization, Basilisk, of course, if you want to see us play video games. It's Kyle Hill Gaming. We're doing a Patreon only podcast with my young ward Adef of Pokemon and Elden Ring speedrunning fame, if you want to check that out over on that website. We also sell Kyle Hill's Nuclear Honey at curiositybox.com/Kyle Hill. I did this with Vsauce. I'm very happy about it. But next year, yeah, actually, in the next 2 weeks, we might have the biggest nuclear news of my lifetime, and I have a video on that. that I'm working with the Department of Energy on. That's why I'm staying home this year. And then next year, I've already written down like almost a dozen places that we're going to go check out, or hopefully check out, everywhere from South Carolina to Tennessee to Australia to Finland to San Francisco I want to bring you as much interesting, educational science as I possibly can, and I hope you join me for that ride. I know I haven't been streaming for months, but we've just been working on a lot of stuff here at La Facilidad. So I hope you forgive me for that. Chat, is there anything else from Fallout that you have a burning question about that I didn't mention from episode 1? Will it be good news? Yes, it's actually good nuclear news. The industry was kind of worried, given that there's not a whole lot of expertise in some places in the government at the moment, but it seems like it's good news. With enough warning, we could easily transport a rocket engine to an asteroid, then a sufficiently sizable nuke. That's a good point, Hassar, in the chat. So people like to... Well, there was decades of trying to use atomic weapons for peaceful purposes, earth moving and stuff like that. Civil engineering kind of works. There was over 1,000 nuclear tests performed just by the United States. But you don't have to nuke everything. As Hassasser in chat said, if you know that an asteroid is incoming and the trajectory is going to overlap with Earth's, you could just send out a very small rocket and rendezvous with the rocket and then just move it a little bit. The good thing about astronomical distances is that if something is 1 million miles away, you only have to alter the trajectory by a fraction of a degree. And by the time it moves 1 million miles, it won't be anywhere near Earth. You know what I mean? So you could do that. Or my favorite method is laser bees. A swarm of robotic bees with lasers that ablate the surface to slowly push it out of its destroying trajectory. Hell yeah. Hell yeah. In your last Fallout VOD, was a radiation dose instantly lethal or lethal over amount of time? The amount of radiation that is instantaneously lethal is very, very, very high. So around 1 sievert is the start of radiation sickness. Between 1 and 5 sieverts, you start going through the first stage of radiation sickness, which is hematopoietic syndrome. And then you go into gastrointestinal. Once you're 3 to 8, gastrointestinal syndrome. That's why it's almost a death sentence if you start vomiting after an acute exposure of a lot of radiation. And then above that, like 8 to 10 sieverts of radiation, is when there's so much that it actually starts interacting and affecting your central nervous system. There is no exposure in history that I know of that instantly killed a person. But in theory, I don't know how much it is, but in theory, a human, you could beam radiative energy at them to such a degree that their central nervous system would shut down and they just instantly die. Straight through their brain or their spinal cord. But I don't know what that exactly is. I haven't looked it up because I'm already on a watch list. But I know that the largest whole body dose anyone has ever gotten is Robert Peabody. He got somewhere between 80 and 150 sieverts. And he almost instantaneously vomited and then defecated blood, and he died in 49 hours. But I don't know of any accident in history where someone died instantaneously from radiation alone. We don't have that kind of data from, nuclear bomb survivors or anything like that, of course. Of course. Yeah, I'm on a watch list mostly because of the eyebrow twitching, yeah. Anyway, Chad. If you enjoyed this, let me know. We can come back maybe next year or after the next episode on the weekends and talk through more Fallout-y, sciencey stuff. If that's something you're interested in and you think I can add to your enjoyment of the content, I hope to see you many more times next year, unless I get disappeared because of my search history. But I know that I'm working on a lot of stuff for all of you. I'm honored and humbled to be a part of your educational journey. So if you want to join me on that, please do. Patreon.com/Kyle Hill. Got a lot of cool stuff for you. Goop, 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 goop. I hope everyone has a wonderful rest of their... I hope that everyone has a wonderful rest of their day, night, evening, dusk, dawn, midsummer night's cream, whatever it may be. No matter where I see you next time, chat, until that time, be nice to each other. Because this is all we got. I'll see you soon.